Online students, is my voice is loud and clear? Done. So just wait for another 5 minutes. We'll start the session. Just 2 minutes, not even 5 minutes, 2 minutes. Just now I have completed the previous class. Wait for 2 minutes. Yeah. Okay, guys. Uh, guys, how many of you have taken the exam at 4 o'clock? Just raise your hand in this class. Okay. So most of the students, offline students has taken and online students done. Okay, guys. So just now I have received your answer sheets and I will do the correction and within 1 or 2 days, we'll share you the result. Okay. By night, you'll receive the solutions. Today night, I'll upload the solutions. You can even cross check. Already you're familiar with the solutions. What are the solutions you have right? Now, I'm going to share you the solutions and you can cross check your marks. Next one is, now in the previous class, we are discussing about the statistics. Okay, so let's continue from there. And so within the statistics, okay, within the statistics, particularly in the previous class, we have discussed the frequency distribution and along with the probability. What is probability and how the probability will be calculated for a continuous variable along with the discrete variable. So in the previous class, we have completed Okay, in terms of probability, first we have discussed probability. We have started with this, and in the probability we have seen how to calculate the probability, how to calculate probability when data was given to us, when the data was given. And what are the data was given? We are going to calculate the probability on discrete variable, and also we are going to calculate on the continuous variable, both on discrete and continuous. Okay, so we have seen how to calculate the probability, how to calculate probability when data was given to you, when data was given. So without the data also we can calculate probability. Yeah? That is second one. Next, I will explain even that. That one we'll discuss in the today's class. Okay, how to calculate the probability when the data was given means for discrete variable also we know, for continuous variable also we know, and for both of them what is the common thing is probability is nothing but number of records satisfy your requirement divided by total number of records. And when you are calculating the probability of discrete variables, in the bracket you are going to write the single value, and when you are calculating the probability for continuous variable, you are going to write in the bracket interval. Right? Next, after calculating the probability, we have discussed the distribution. What is meant by distribution means the what are the data was given to us, it is called as distribution. If it is continuous variable, distribution. For discrete variable, what is distribution means? For discrete variables, the distribution meaning is unique values. What are the unique values are there? That unique values are called as distribution. Means in this particular column, these are the values are there. What values will be there? Which are the values? For example, in the gender column, male, female, male, 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 female, female, male, 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 something you are having like this. In the entered data, what are the things are there? Means males are there, females are there. So distribution means basically for discrete variable, unique values. For continuous variable, what is meant by distribution for continuous variables means it is nothing but your intervals. What are the intervals you are going to consider? That one. Now, what is second one we have discussed is frequency distribution. Now, what is meant by frequency distribution means you have to consider the frequency on the y-axis, distribution on the x-axis. Frequency on y-axis and distribution on x-axis, whether it is for continuous or whether it is for discrete. Whether it is continuous or discrete, this is the same which you have to do. Now, what you have to take means, please make a note of this example in the notes. Which example? Just to give me 1 minute. Everyone, please make a note of this example in the notes. From here to here. Okay, it would be difficult to write all the values like this. So even online students and offline students also, please take the screenshot. Okay, it will be difficult to write these many values. I can understand. So don't unnecessarily write. Just take the photo. Open your mobile phones and take the photo of that. And when I'm explaining, please open your mobile phone also side. Open your mobile, open your mobile phone, open that image. Because that is the data, na? So on that data only we'll calculate all of them. Each and everything we'll calculate on this data. Everyone has completed photo and screenshots, both offline and online students. Okay, now keep the screenshot with you or keep the photo with you, and for this data let us apply one by one. What are the things we are going to apply means, first let us take the discrete variables. Let us go with the first one called as discrete. For discrete, what we will do means, we calculate the first probability. Separate first, instead of probability, first we will go with the distribution. Same logic has to be applied for the continuous also. First, what you want to have to do, distribution, followed by frequency distribution, not frequency distribution, frequency table, followed by frequency distribution. Okay, followed by, in terms of, next one is called as probability distribution. Probability table, let us add the probability table and also the probability distribution. Total everything let us add. All the 5 has to be done on the continuous variable. All the 5 has to be done on the discrete variable. Now first let us start with the discrete. Now in your data set, what is the discrete variable you are having is, the first column is discrete variable gender. Now just open your, what are the image you have taken. In that, tell me what is the distribution you are having. Gender has what are the values? Male and female, M and F. Sorry? Sorry? T. Third one also is there. Total 3 are there. Okay. So 3 unique values. Okay. Male, female and T. MFT. 3 unique values are there. Whether it is M, M is male or female, that is irrespective. Just letters are there. M letter is there, F letter is there, T letter is there. Now, what is the second step? I told you, frequency table. As per the alphabetical order, first F, followed by M, followed by T. How many F's are there? 7. How many F's? 7. How many M's? How many T's? 2. This is called as what? Frequency table, where you are having the category along with their frequency. Category along with their frequency in a table. Or sir, why we call it as category, sir? This you told now, unique values means distribution. Okay, this is also distribution only. Frequency distribution. But frequency distribution you are representing on a graph or in a table means in a table. So it is called as frequency table. Now the same thing you represent in the plot. Now what is the plot you are going to use means count plot. And you are going to have, what is the count plot? First one is females with a height of 7. Where the height of 7 is there? Females. Males also with a height of 7. That is M letter with a height of 7 and T letter with a height of 2. F letter with a height of 7, M letter with a height of 7 and T letter with a height of 2. And what is this plot is called as count plot, where it is going to represent on the y-axis frequency, on the x-axis distribution. In statistics, it is called as frequency distribution. So the same thing I'm writing here. See, in the code, now I'm entering into the code. In the code, first I'm going to take this one, 7, 7 and 2. Now I'm going to take in terms of SNS dot count plot. What is SNS means? I'm going to import the CBurn. What are the CBurn is there? I'm going to import the CBurn as SNS, where CBurn is a data visualization library, like similar kind of pandas. It is particularly in this plots are available. Every function is a plot. In the CBurn only, first already one function we have completed. What is that function is? Box plot. In the CBurn, we are going to use the one more function. What is this function name is called as count plot. And see, you are going to get males are 7, females are 7 and T's are 2. This is called as frequency distribution. How to write the code? For which variable you want to select the distribution, write that variable and SNS dot count plot. Inside the count plot, you have to just provide the data as categorical data. Okay, completed. Next, what is the next step I told you? After frequency distribution, what do you have to calculate? Probability. Sir, how to calculate the probability of individual value means, here you are going to calculate the probability of individual value like this. See, tell me manually how you will calculate. If you have to do manually, this is frequency table. How you are going to calculate the probability for females means how? 7 by 16. What you are dividing with the total. Total only na? So same. Here value counts. Now value counts means what is the output I am going to get means for each category what is the number of values are there. Males are 7, females are 7, T's are 2 are there. Now with what I have to divide? With the 16 I have to divide. So which is nothing but length of DF. When I divide with length of DF, automatically I will get the values. That is nothing but probability. Now in the count plot, I am going to write X is equal to gender. X is equal to gender means on X-axis what I am considering? Gender. On the Y-axis, stat is equal to probability. Stat is equal to probability means what it has to calculate. Probability has to be calculated and it has to represent the probability. Now on the Y-axis what is there? Probability. In the earlier Y-axis what is there? Count. So what is the difference between this one versus this one means by default it will take the stat is equal to count. If you don't write also it will take the count only. By default it will take the count. That is default argument. Count is the default argument. When you want to calculate the probability, you have to write clearly probability. Then you are going to get the output, and what is distribution? This distribution is called as probability distribution. All of them are clear, guys? Distribution I told you, table I have told you, frequency table, probability table. In the Python, how to see the probability table means what are the value counts divided by length of DF. So just what are the value counts is there? Length of DF is one way. Second way is second option. What is the second option you are having? Means what are the value counts is there? In the bracket, normalize is equal to true. If you write like this also same answer. This one and this one. Sir, what is meant by normalize is equal to true? Normalize is equal to true means divide every value with the maximum value. That is nothing but total value. The meaning of normalize is equal to true means divide with the total. If you write directly like this or if you write like this, answer is same. Point is clear? Everyone. So all of them are completed, including the Python code also. I have shown you the frequency. For getting the distribution, what you have to do? Dot unique. For getting the frequency table, what you have to do? Dot value counts. For frequency distribution, what you have to do? Count plot. For probability table, what you have to do? Dot value counts divided by the length of DF. For frequency, probability distribution, what you have to do? Again, count plot only, stat is equal to probability. Every code is clear? Python code for everything. Now let us apply the same thing on the continuous variable. Distribution, frequency table, frequency distribution, probability table, probability distribution. Let us apply the same thing on the continuous variable now. If you are having any question, please ask before moving on to the continuous variable. For continuous variable also, I am applying the same logic as it is like this. Now, first distribution. For continuous variable, what is distribution means? It is not unique values, it is intervals. Intervals. And intervals are also called as bin. One interval is called as one bin. Now, how you are going to decide the interval size? Okay, here bin size or interval size. What are the bin size is there? Your bin size is equal to maximum minus minimum divided by number of bins is equal to bin size. So for the distribution in the discrete variable, what is distribution in the discrete variable means? Unique values. It is very simple. Simply taking the unique values. What are the unique values are there? Unique values are called as distribution. But whereas coming to the continuous variable, what is the distribution means? Interval or bin. Now, let's take this example here. Okay, in your, what are the photo you have taken? In that marks, open the marks column. For the marks column, first tell me what is the maximum value? 100. What is the minimum value? 30. These are the first. Okay, this is clear now? Sir, in my data set, you have given the values like this. For example, 10 lakh records are there. Then df of marks dot min, df of marks dot max. You will get right. Here images records are less records. You are seeing manually, that to have kept in the ascending order for your easiness. Okay. Now, how to calculate the bin size? Bin size you have to decide. Now you want to check the students' marks between 30 to 40 or you want 30 to 50, anything, something you fix in your mind. But that one should be equal interval. You can't take from 30 to 50, 50 to 90. You can't take like that. Sir, if I want like that, sir, then I told you discretization. Do you remember? Convert the continuous variable to discrete variable. How many categories you want? So for example, 30 to 50, I am considering as category 1. 50 to 75, I am considering as category 2. 75 to 90, I am considering category 3. 90 to 100, I am considering as category 4. Here equal interval or unequal interval? What is meant by interval? Size. Interval size is equal size or unequal size? Unequal. When it is unequal, then in that case, you have to go with the discretization. And you have to cut that one, 30 to 50 as one category, 50 to 75, 75 to 90, 90 to 100. You have to use the bins is equal to like this and labels is equal to, and you have to convert as per your choice. But when you are considering a continuous variable as a continuous variable, then you have to take the equal interval. Equal interval. Now, so I am going to consider here the interval of 10. Okay, interval is 10. Interval or bin size. Interval, or which is also called as bin size, is equal to 10. Sir, why 10 means? That is my requirement. As I have told you now, if you are interested with 15 or if you are interested with 20 also, you can go. As per your choice, you can go. Point is clear? Now, Interval size is 10. Now here I am writing the interval. Okay. Now what are the intervals we are having? Distribution. As I have told you, distribution means nothing but interval. Now what is the intervals you are having? So finally your distribution. For this example, what is the distribution you are having means? What are the distribution? Interval of 10. What is the starting value? 30. After 30, what is the next number you have to write? 40. What is the next number? 50. What is the next number? 60, 70, 80, 90, 100. This should be on the x-axis. What should be on the x-axis? Value should be on the x-axis. Interval should be on the x-axis. Right? Now, here I am going to take the first, observe this one, don't write simultaneously along with me. Just keep the image and tell me the answers. Slowly we will discuss. This is only more important. First, interval. I am writing here interval. Heading as interval. And the second one is frequency. First, interval of 30 to 40. How many records are there? 30 to 40, how many records are there? One record. 40 to 50, how many records are there? 50 to 60, how many records? 60 to 70, 70 to 80, 80 to 90, 90 to 100. And this is called as what? What this is called as? Frequency table. What is the difference between the discrete frequency table versus continuous frequency table? What is the first column name there you have used? Category. Here what is the name for the first column you are using? Interval. Second column name, what is the second column name? Frequency. Here also it is frequency. Only difference is instead of using the category word, we have to use the interval because it is not individual value. It is interval. Point is clear? For continuous variable, what we have to use? Interval. For discrete variable, what we have to use? Individual value, single value. What is this called as? Frequency table. Now, let's represent this one on the x-axis. As I have told you, on the x-axis, what should be there? X-axis has distribution. Y-axis has frequency means frequency distribution. Probability means probability distribution. Now, I am going to draw the frequency distribution. So, on the x-axis, I want the distribution. What is distribution means? 30. After that, what is the next number I have to write? 30 to 40. So, 40. Again, 40 to 50. Already 40 number is there now. Again, I have to write 40 number. No need. So, 50. Next, I am writing 60. Next, I am writing 70. Next, I am writing 80. Next, I am writing 90. Followed by, I am writing 100. Actually, I have to write 30 to 40. If 40 is not available, I have to write one more time. But already 40 is there now. Same 40, why to write two times? Is that clear? What is this called as? Now, on the y-axis, we are going to take the frequency. Now, 30 to 40, how many records are there? One record is there. Now, 40 to 50, how many records? Two records. Now, tell me the question, should I attach the bar or should I not attach the bar? Means attach. Why? Because 40 is common in both of them. 30 to 39, for example, 30 to 39, 40 to 49 is there. Then in between gap should be there. That minute gap should be there. That 1 point gap will be there. But here the gap will not be there. Sir, then you can take 30 to 39. No, sir. If I take 30 to 39, For continuous variable, decimals are allowed or not allowed? For continuous variable, you may get the decimals or not. Possible or not possible? Possible. In continuous, it is possible. In the discrete count, it is not possible. For continuous variable, decimal are also possible. Means, in your case, marks are not having decimal values, means marks will not have the decimal. Will also have na. For example, any student has got the marks of 39.5. Then where you will add that one? So if you take 30 to 39, after that 40 to 49, if you get 39.5, where? Okay, sir, 39.9. 40 to 49.9. Okay, 50 to 59.9. Okay, assume. Now, if you are considering up to 39.9, if you are having the marks of 39.95, where you will add? Point is clear? Now, that is the reason why we consider as like this. Now, again the question will come. Sir, if exactly 40 is there, then it comes into this category or this category. In that case, what we are going to do means, by default, right side is not included. Default, right side is not included. For the last one, automatically right is included. For last one, right is included. That is 100 is included because next is not there now. For remaining all of them, right side is not included by default. So for exactly 40 is there. Now it comes under which category? 30 to 40 category or 40 to 50 category? 40 to 50 category. Point is clear? Everyone? That is default. Now here the bars are attached to each other. And 50 to 60, the bars are attached to each other. 60 to 70, 70 to 80, 80 to 90, and 90 to 100. Everyone is clear? Anyone has doubts? And this diagram is called as histogram. And histogram should be applied on continuous variable or discrete variable? Continuous variable. For discrete variable, count plot. So for discrete variables, different plots are there. For continuous variables, different plots are there. We cannot use the same plot for both the types of variables. Histogram, H-I-S, H-I-S, histogram. Clear, guys? This is called as frequency table. Before to the frequency table, first I have explained for you the distribution, followed by frequency table. Frequency table is clear up to now? Anyone? Any questions? Now, let's start discussing the probability. Now, let's start discussing probability. Now, probability, are we going to calculate for single value or for the interval? Interval. Now, I'm going to calculate what is the probability of 30 to 40. What is the probability of 30 to 40, miss? What is the probability? Probability for the same interval. What is the probability? 1 by 16. Total 16 records now. How many records satisfies between 30 to 40 divided by total number of records? That is the probability meaning. My question is, what is the probability of 30 to 40? How many records are there? Satisfying that requirement means 1. Out of total how many? 16. What is the probability of 40 to 50? 2 records satisfy your requirement, divided by 16. How many records are between 50 to 60? 3 by 16. 4, this one is 4 by 16. 5 by 16. 6 by 16. Sorry. 3 by 16, 2 by 16, 1 by 16. What is the sum of the probabilities? 16 by 16, 1. How you get 1 means, since denominator is same, numerator we have to add. Obviously 16 by 16 will be there. Now what is this table now? Probability table. Of course, you have to remove the frequency, not required. This column is not required. Interval and probability. This is called as probability table. Now, I'm going to draw the diagram. Now on x-axis, what have for probability distribution? On x-axis, what have to consider? X-axis distribution. On y-axis, probability. X-axis I'm taking in terms of again 30 to 40, 50, 60, 70, 80, 90, 100. Now I'm going to take the for the first one 30 to 40 probability 1 by 16, 2 by 16, 3 by 16, 4 by 16, again 3 by 16, 2 by 16 and 1 by 16. Only difference is here earlier it is 1, but it is not now 1. It is 1 by 16 value. On y-axis 1 by 16, 2 by 16 value, 3 by 16 and 4 by 16. These are the y-axis values now. Now on x-axis what is there? What is there on the x-axis? Distribution. On the y-axis what is there? Probability. Both combined. Probability distribution. And this is applied on a continuous variable or discrete variable. Then what is this called as? Continuous probability distribution. Everyone is clear? Yes or no? All of them are clear? What is meant by distribution? Everything with an example. That is the reason I asked you to take that data set, and for that data set only I calculated each and everything. Clear or not clear? For continuous variable, what plot you have to apply? Histogram. For discrete variable, count plot. Right? So now see here I'm going to take the distribution. Since it is a I'm applying the histogram. Can you see here? SNS dot hist plot on DF of marks, and bins is equal to 7. Number of bins is equal to 7. What is number of bins? I told you interval is equal to maximum minus minimum divided by number of bins. Now interval I have locked to 10. Maximum value in my data set is 100. Minimum value is 30. Then what is the number of bins value? Automatically 70 divided by 10, which is 7. That one only I am writing here. When I have written here number of bins is equal to 7, it is going to calculate the bin interval size as 10. Now what is the interval size it is going to consider? Interval size 10. For example, sir, you have taken this is maximum value 100, sir. Minimum value is 30, sir. You have taken the number of bins is equal to 10, sir. Now in this case, what is the interval size? 100 minus 30 divided by 10. And what is the interval size you are going to get? 70 by 10, which is 7. Now what happens? 30 to 37 as 1, 37 to 44, 44 to 51, 51 to 58, 58 to 65, 65 to 71, or sorry, 72, 72 to 79, 79 to 86, 86 to 93, 93 to 100. These are the total. Total how many you got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Total 10 will be there. Is the point is clear? First 1, 2, 3, 4, 5, 6, 7, 8, 9 and last one is 10. Total 10 are there. Is that clear? If you write number of bins is equal to 10 means you are going to get the 10. If you write here 7 means then what happens? The interval size is going to be considered as interval. If you write the number of bins is equal to 7, what is the bin size? 10. Size will be 10. So 30 to 40. Bins will be how many? 7 bins will be there. What is meant by bin means? 1 bar. These bars, how many bars are there? This one bar is called as 1 bin. If you write 7 means it will take 30 to 40 as 1 bin. If you write 10 means it will take 30 to 37. Is the point is clear, guys? So here I am writing the 7. Can you see total how many bins you have got? Clear? Now let me take here 10. Observe this one. Now again count. How many are there? 1, 2. Of course gap is there. Here no, none of the value is there. 0 records are there. But it is also considered as one of the bin. 3, 4, 5, 6, 7, 8, 9, 10. Here value is not there. That is the reason it has not drawn even one height also. If value is there, it will draw. Now, for example, if I take number of bins is equal to 12, how many you are going to get? 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. According to that, the interval size will be adjusted. So, since I have written here 7, if number of bins are 7, automatically the interval size will become to the 10 as per the formula. Every time are you going to take 7 only? Yeah? No, it depends on the minimum value and maximum value also. You have to check the minimum value and maximum value. And according to that, you have to fill. For example, let's take like this. You got the minimum value as 0, maximum value as 100. Now, if you take the number of intervals, number of bins is equal to 4. Number of bins is equal to 4. Then what is the interval size will become? 25. Means 0 to 25 as 1, 25 to 50 second, 50 to 75 third, 75 to 100 will be the fourth. So the interval size is going to become the 5, 25. Number of bins are 5. Then what is the interval? 20. If number of intervals is equal to, number of bins is equal to 10, then what is the interval? 10. Like that. As per your choice, you are going to choose. Sir, which one is making sense for you? That one you have to apply. Okay. Here there is no fixed rule. Sir, for example, if I take the number of bins is equal to 6, what happens means you will also get in terms of 6 the interval size accordingly. But how many students are there between 0 to 11.67? 11.67 to 23.25. There will be user. Point is clear? In that way, you have to check yourself. If I take the number of bins like this, interval size is coming like this, whether that interval size will be used or not used for you. There is no fixed rule. Guys, remember this one. If everything is fixed means, remember, this is most important. Write in the notes if required. If everything is fixed means there is no use of hiring a person. There is no use of hiring any person because everything will become to the automate. Reason is, if I know this one, first this one, after this one, after this one, if I know, I can't write the steps and I can't create a user defined function for that. And automatically it will only take the data, it will only do that one, and if and else I can't write. If this is the case, do like this, elif do like this, else do like this. I can't write if and else. If I write everything if, elif, 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 elif and write this, and if I create a user defined function or user defined module, then what is the use of you? It will only take the data. If this is the case, do like this. If this is the case, do like this, else do like this. Everything is backend code is there now. Point is clear? Why automation is not there in the data analysis? In other cases, automation is there. In the data analysis or data science, why automation is not there means this is the reason. Humans only knows because here, see, when I apply the describe function, observe this one clearly. What is describe function means? It gives all the descriptive statistics values, right? Now, observe this. I'm taking the pandas. What are the tips data set is there now? Okay, this is the tips data set. And after loading the tips data set, here I'm going to take df.describe. Means when I write the df.describe in the entire data, which are the numerical values are there, it will apply for each and every column. Here, what are the columns, numerical columns are there? Total bill, tip amount, size. For three of them, it will apply. But whether it is a correct one? Whether it is a correct? No. Why? Because the mean, standard deviation, all these things has to be calculated only on the continuous variable. What it has done? It has applied on the, on which column it has applied? Count variable also it is included. You have to apply the logic of this one, and you have to write internally, apply only on the total bill column, comma, tip column. Only these two columns you have to write. You have to write like that. Which are continuous variables? Only continuous variables you have to select. You should not write the count variables in that. It will give, it will say, because as per the Python, which are the numbers are there, what are the numbers are there, every number, adding all the numbers divided by total, mean will be calculated now. Even if you give like this, how many number of mobile phones are there means one person is having one mobile phone, second person is having two mobile phones. What is the average mobile phones means 1 plus 2 divided by 2, 1.5 is the average. Max wise it is completed. Logical wise only it will not be completed. What is this 1.5 mobiles for? When you are going to present to others, if you say in the class students are having 1.5 mobiles and average means, that only will not make them sense. Max is completed or not completed means max is completed. For doing the max, numbers are sufficient. Logic is not required. Numbers are sufficient. 4 plus 9 plus 15 plus 3 plus divided by 4. And what is the answer means? For max, okay. But for statistics, what is this 4 values? 4, 9, 15 and 3, if you write like that, what is that? First tell me what is that. Later I will tell you whether mean can be applied or not. That is the difference between a normal max versus analysis. For every number we can't apply the mean now, blindly. Points are clear? In which case it is applicable, there only we have to do. Right? Now, so that same thing I am saying. Here also, you have to apply the logic. Which one is making the sense for you? And according to that, you have to select the interval. Right, guys? Now, what is this is called as histogram, histoplot. So what are the plots we have covered, miss? First plot name is called as box plot, applied on which type of variable? Continuous. Second one is called as what plot? Count, applied on discrete variable. Now histogram. Third one is histogram, applied on continuous. Right? Now, sir, this is okay. You told probability distribution, no, sir. This is frequency distribution or probability distribution? Frequency. How you know? Because on y-axis, count word is there. Based on the y-axis name. The y-axis name is called as Y label. Y label. Now, here I want the static, instead of frequency, I want to calculate the probability. Then what I have to write? Stat is equal to probability. Now, what is the output you are going to get is called as probability distribution. In the same histogram, you can get the frequency distribution, you can get the probability distribution. Both of them are clear? If you are having any questions, please ask. Now, one of the student is asking, what is the purpose of that much plots representation? You see now, one by one. Can't we get the data representation from one plot to everything? No. You see, one by one. We will get one by one. Okay, we'll enter into that, right? When we are entering, you can understand everything. Now, coming to this. Now, what are the plot frequency distribution you have drawn now? Some plot you have drawn the frequency distribution. And what are the plot you have drawn? I'm drawing one more time here. Thirty to 40, 40 to 50, 50 to 60, 60 to 70, 70 to 80, 80 to 90, 90 to 100. Now this is the histogram which you have received. Now this histogram is symmetrical or unsymmetrical. What is meant by symmetrical? Symmetrical means first you have to take the center value. Okay, 30 and 100. What is the center value for 30 and 70? 30 and 100. What is the center value? Which is nothing but average value. Starting number and ending number. And 30 plus 100, 130, 130 by 2, which is 65. 65 will be considered as center value. So at the center value, draw one line. Now left side and right side. Left side and right side, check the diagram is same or different. If it is same, it is called as symmetrical distribution. If it is not same, it is called as unsymmetrical distribution. Point is clear? Next heading is types of distribution. Types of distribution. Heading. Now, heading is types of distribution. What are the different types of distributions we are having, miss? First one is called as uniform distribution. Starting with first one is uniform. Uniform distribution. Second one is called as non-uniform distribution. Non-uniform distribution. Now, within the non-uniform distribution, which is non-uniform, in that again we are having subcategory symmetrical distribution. Second one is called as unsymmetrical distribution. And all these things are applied only on the continuous variable. Only on continuous variable, not on discrete. Only on continuous. Right? Now, first, let's start with the uniform distribution. Earlier you have taken one image, right? Again, now open. Open that image and there is a column called as UD. Column name number 3. UD. For that UD column, draw the histogram. You only draw. Let's see. By creating the number of bins is equal to 4. Number of bins is equal to 4 and draw the UD for the UD diagram, for the UD column histogram. Number of bins is equal to 4 means what is the interval size you have got? What is the minimum value? 9. What is the maximum value? 10. What is the interval size? 10 minus 9 divided by 4, which is 1 by 4, 0.25. Now starting value 9. Second value what do you have to write? In the distribution 9.25 followed by 9.5 followed by 9.75 followed by 10. Now draw the histogram. Done? So this is the histogram I am drawing here by considering the UD. The column name is UD. SNS dot histplot of UD and number of bins is equal to 4. And when I have drawn every bin of the same height, when every bin of same height is there, it is called as uniform distribution. All the bins are in the same height is called as uniform. All the bins are in the same height, it is called as uniform. Sir, this is called as binna bara. That is the question. Within the count plot, we call it as bar. Bar word should be used for the discrete variable. Bin is the word has to be used for the continuous variable. You should not use the word called as bar. This one, what of this one is there? This one you should not use the word called as bar. You have to use the word called as bin. Sir, in the count plot, you have to use the word called as bar. Why, sir? Because that is discrete variable, this is continuous variable. Clear? Now, draw the histogram for the next column X by considering the number of bins is equal to 7. Number of bins is equal to 7 for X column. Draw the histogram. Completed? Now, by number of bins is equal to 7, the histogram. What are the histogram you have done on the X? And what is the diagram you have got is this one. Now, whether it is a uniform distribution? No. All the bins are not in the same height. It comes under non-uniform. Now, when it is non-uniform, within the non-uniform, what we are having? Symmetrical, unsymmetrical. So, whether it is symmetrical or unsymmetrical? Symmetrical. Now, again, example for symmetrical is completed. Now, to take the Y column and draw the histogram by considering the number of bins is equal to 7. Y column. For Y column, draw the histogram. Number of bins is equal to 7. Completed? Now, whether it is a symmetrical uniform? No. Whether it is symmetrical? No. It is not even symmetrical. So, unsymmetrical. It is a unsymmetrical distribution. Now, within the unsymmetrical, which side you are having the less number of records? Which side you are having the less number of records? Right side or left side? So, what is meant by less number of records? So, this side you are having 1 record, 2 records, total is 3 plus 6. 1, 2, 6. What is the total number of records? 9. Right side 1, 1, 1. What about this one? This is center 9. I also don't know. So, let us assume here 2, here 2. Total 4 are there now. Left side 2, right side 2. Now, which side you are having the less number of records? So, right side 5 records are there. Left side 1 plus 2 plus 6 plus 2. Total more number of records are there. So, right side you are having the less number of records. So, it is called as right skewed. Unsymmetrical distribution is also called as asymmetrical. or which is also called as skewed distribution. Skewed means one side will be less. Unsymmetrical distributions are called as skewed. Which side is skewed? Right side or left side? Right side skewed. It is right skewed. Now draw the histogram for the Z column. Last balance, one column is left. Draw the diagram for the Z column. Completed? By considering the number of bins is equal to 7. Completed? Everyone. Now, whether it is a uniform for Z column, whether it is uniform? No, it is non-uniform. Within the non-uniform, it is symmetrical or skewed? It is skewed. Left side or right side? Which side you are having less number of values? Left side or right side? Which side you are having less number of values? So you are having in terms of left side less number of values. So it is called as left skewed distribution. So 1 column for 1 example. Basically, in that data set, what are the numbers you are seeing? 1 column is for 1 example. UD column is for uniform distribution. X column is for symmetrical distribution. Y column is for right skewed distribution. And Z column is for left skewed distribution. So 1 column I have created for 1 example. Is that clear? Completed? Anyone? Any questions? Left skewed, right skewed. Now symmetrical distribution, another name of symmetrical distribution is, okay, another name of symmetrical distribution is called as normal distribution. Another name of symmetrical distribution is normal distribution. Sorry. In the given data set, you are having 0. From 0 to 10, how many values are there? Between 0 to 10, how many values are there? One record is there now. How many values are there in that? In that given range, how many values are there? Between 0 to 10, only one value is there, right? 0 is there. So one value are drawing. Right? Now, again, everyone draw the frequency table for the marks. Draw frequency table for the marks. Frequency table. By considering the interval size of 10. Draw the frequency table for the marks with an interval size of 10. Interval size or bin size, whatever it is. Frequency table with bin size of 10. Table for marks, table, not the distribution, table. Interval frequency 30 to 40, 40 to 50, 50 to 60, 60 to 70, 70 to 80, 80 to 90, 90 to 100. And this is 1, 2, 3, 4, 3, 2, 1. Done. Frequency table is completed. Now, completed, guys. Now, next concept is called as cumulative frequency. Cumulative frequency. Okay. Next one is cumulative frequency. Yeah, bin size I am considering as 10. Size is 10 or number of bins is equal to 7. Both are same only, right? Meena. Number of bins is equal to 7. Bins are 7. Automatically size will become the 10 only, right? Clear, Meena? Now next one is called as cumulative frequency. What is the difference between the frequency versus cumulative frequency? Means frequency is calculated only for that interval. Cumulative means it's a combination. It's a combination. What is the probability? What is the frequency means from 30 to 40? How many records are there? 1. Cumulative frequency 30 to 40 also it is going to be 1. Whatever the number is there, that same number. First one will not have any difference. Second one, from 40 to 50, how many records are there means 2. That is called as frequency. What is cumulative frequency means 30 to 50, not 42. First number to ending this number. 30 to 50, how many numbers are there? The combination of these two, which is 3. That is called as cumulative. 50 to 60, how many records are there? 3. Cumulative frequency means 30 to 60. First number to this number. How many are there? 6. Cumulative frequency 30 to 70. How many? 30 to 80. 30 to 90. 30 to 100. This is only called as cumulative frequency table. Point is clear? So every time the first number to that number, including from there to there. If you are asking the question, what is the number of records? Total how many records are there between less than 80? If you are asking the question like this, number of records less than 80. What is the meaning means? It's a combination of 30 to 40, 40 to 50, 50 to 60, 60 to 70, 70 to 80. It's everything. The minimum value to 80. If you are asking the question, how many are there less than 70? What is the meaning of this? Minimum to 70. Less than 100, minimum to 100. Less than 90, minimum to 90. Automatically, the first number is going to be the minimum. Point is clear? H-down I told you, right? So whenever they have given how many records are there, marks less than 90 means automatically from the minimum value to 90. That minimum value to 90 calculation only is called as, always from the minimum value to that particular value is called as cumulative frequency. Cumulative frequency table is clear for everyone? Draw one more table. In that table, I want the probability. Interval along with the probability. I want the probability table, guys. Draw the probability table for the marks. Probability table. Separately. Draw separately. Yeah. Simply write 1 by 16. No need to calculate that one. No need to calculate the decimal. Simply write 1 by 16. Sufficient. Interval 30 to 40, 40 to 50, 50 to 60, 60 to 70, 70 to 80, 80 to 90, and 90 to 100. What is the probability? 1 by 16, 2 by 16, 3 by 16, 4 by 16, 3 by 16, 2 by 16, and 1 by 16. Now tell me cumulative probability values. First one is 1 by 16. 3 by 16. Next. 6 by 16. Next. 10 by 16. Next. 13 by 16. 15 by 16. 16 by 16, which is 1. This is called as cumulative probability. What is the difference between probability between 70 to 80 versus probability less than 80? What is the difference? Here you are asking a normal probability. Here what you are asking? Cumulative probability. When you are using the less than symbol for greater than symbols, literally you are asking the cumulative probabilities. Whenever you use a less than symbol, remember you are asking the cumulative probability. Now, what is the probability of x less than, x means marks. Marks less than 80. What is the answer? Marks less than 80. What is the answer in this example? Less than 80 means minimum to 80. What is the answer? 13 by 16. Automatically. Number of records satisfies records less than 80 divided by total number of records. Same answer will be there. If you want, you can check in your data set also. How many records are there less than 80? Less than 80 means nothing but this one. Now I am asking the question, what is the probability of marks greater than 80? Greater than 80 means simply 1 minus probability of marks x marks less than 80. Whenever they ask the question greater than, you have to take 1 minus less than, because always less than will give the cumulative probability. In the cumulative probability, every time minimum to that value, minimum to that value, minimum to that value. So always we are going to take in terms of, so what is this cumulative probability means? Basically it is less than 40, less than 50, less than 60, less than 70, less than 80, less than 90, and less than 100. So whenever they ask the question greater than, what you have to do? 1 minus 13 by 16, which is nothing but 3 by 16. So more than 80, how many are there? 3 are there. 3 by 16. So whenever they ask the question greater than, we have to do 1 minus. We can't directly calculate the greater than, because cumulative probability will be calculated from the minimum to that value. Minimum to that value means you are going to get by using the less than symbol. When they ask the question greater than, 1 minus. Sir, why 1 minus, sir? Because both the combination less than 80 plus more than 80 total is going to be 1. Sum of the probabilities are 1. 1 minus. Clear, guys? Because exactly equal to 80. You are asking exactly equal to 80. Na? I told you that generally will not go with the continuous variable with a single value. Always will go with a interval. Point is clear? Now you are asking in this question 80 is included or not? In the bottom one. In this it is included? First tell me in this it is included? No. Automatically in this what happens? It will be included. 1 minus half that. Is the point is clear? Opposite to that now. Here not included means here has to be included, right? Because less than opposite is this one now. Opposite to each other. Both are. Everyone else clear? Anyone has any questions? Cumulative frequency and cumulative probability. If you are having any questions, please ask. What are the questions you are having? Ask. So if you are having any questions, please ask, guys. Yeah, as guys, as we have discussed earlier, my mail ID is srk.nareshit@gmail.com. What are the questions you are having? You can connect with me on the mail ID. My mail ID is srk.nareshit@gmail.com. For the test, you are going to share your test answers. You are going to share to the SRK mock test. Okay, that is different. This one is if you have doubts and you want to discuss with me, you can directly send to srk.nareshit. Okay, this is my mail ID. And second, we are going to create the WhatsApp group. I'll intimate to the admin and he's going to create the WhatsApp group exclusively for us. And what are the present WhatsApp community is there now? In that, even the registered students are there, non-registered students are also is there. So we are going to separately have with the registered students a separate group, and it will be created by most probably by tomorrow. I am assuming. I'll intimate to the team and they are going to create. I can't create because your phone numbers are not there with me and I should not also collect. That is not the part of my work. I should not do that. Okay. It has to be done only by the Naresh IT team. So they are going to collect this one and we are going to share you that one and you can create a separate WhatsApp. Okay. I'll ask the team to do that. Most probably by tomorrow, you'll get a WhatsApp separate link. And this is my mail ID. And now coming to the next one, already we have shared for you the notes. Open your Google Drive. In the Google Drive, there is statistics. Inside that, notes is available. Today's notes is also included. Not only today, tomorrow's notes also included. Just you have to scroll up. Okay, just scroll up. Notes is available. Okay. Now, apart from that, just open the daily task. In the task, we have uploaded the descriptive statistics task. Task for the descriptive statistics. Yesterday we have uploaded the task for the pandas. So today we have uploaded the task for the statistics, descriptive statistics till what we have completed today. And tomorrow's again one more task you are going to get. Okay, descriptive statistics with the task one more you will get. As of now, we have shared some of the questions for your practice purpose. Open your daily task folder. In that there is a descriptive statistics task is available. Clear, guys? Done? So that is the end of the session for today. And we'll continue in the tomorrow's class. If you are having any questions, you can ask. Done, guys. Thank you. Thank you all. If you are having any questions, please ask. If no questions, you can leave. Yeah, Rohit, you can ask what are the questions you are having. Rohit Kumar. Rohit, are you having any questions? Swati. Yeah. If you're not having any questions, you can leave.
Our college campus decided visit Hyderabad. Sir, HOD call us. How any startup company? So he's saying means you working or internship na any startup company or maybe any startup company. So we can visit our startup company. Startup company. So about provide to hiring from HOD.
What I have to provide? I didn't understand your question.
Actually, sir, me